All right, my name is Lyle Kaczynski, and I am presenting on incremental sheet forming today. What is incremental sheet forming? I first heard about it. It came across my feed in my YouTube channel or YouTube account. Some of you may recognize um, Destin from Smarter Every Day, and he did a video on it. I think it was a couple months ago now, but it has a very catchy thumbnail with him and a big 6-axis robot doing stuff. So I thought that was pretty interesting, and I watched it, and it was a pretty interesting technology. It reminds me a lot of 3D printing, and I guess machining toolpaths, how um, you kind of have a robot or an interface do successive tool paths into or out of a material to create geometry. So that was how I first heard about it. Um, like I said, it's performed by robots usually, 6-axis robots usually, and there's two kind of methods of doing it, which I'll cover in a second. Um, but um, the tool paths look like you would see in 3D printing or in machining, where you have an end effector following a trace going around and pushing into material. And that's kind of where it gets its name, incremental, because you're doing deformation on an incremental level going into a surface, slowly kind of working your way into it. So you start by having a piece of sheet metal kind of fixed in a frame, like you can see on the right here, and then you have the robot and the end effector pushing into that, deforming um, deforming the material and making a shape similar like you would see in stamping, the stamping process. So you can make a lot of geometry that's very similar to stamping, a lot of parts that are similar to stamping. So there's two kind of ways of doing this. Mainly it's your single point incremental forming, which you can see in my little diagram here. You have the end effector on the left, you have a backing plate on the right, and you have this blue piece of sheet metal. And you would have the robot push into that sheet metal, kind of using the backing plate as a stop to do the incremental forming. And as you go through each layer in your slicer, you would increment your sheet metal, in this case to the left, the frame, so that your end effector is kind of always pushing against that backing plate. And you can see a picture on the bottom right of a robot doing that. Um, then there's the double-sided incremental forming, which really enables a lot of extra geometry, or a lot of intricate geometries to be created. And this is the area that there's a lot of development happening right now with very complicated control systems and sensors and algorithms and stuff like that to enable different geometries. So instead of having a backing plate, you essentially have another robot performing the backing support. And by doing that, it's a pretty simple diagram I have here with the robots kind of in the same, almost in the same axis, but you can turn the different end effectors to get different types of overlay and perform really interesting geometries that you wouldn't be able to do with stamping unless your mold was separable. Um, so here's a comparison of the two. You can see in this B section, the moving support tool, how it's on an angle now, so you can do different angles to support different geometry and stuff like that. You could also have the 6-axis robots load in other types of end effectors like plasma cutters or metrology, sensor type tools to perform checks of your parts. You could also load in sanders to help with your surface finish and stuff like that. And like I said, the process is very similar to stamping, which you can kind of see on the right, that can do a lot of the same things, but there's some drawbacks and some advantages to incremental sheet forming. So for the pros and cons, real quick list. Pros of the incremental sheet forming is that you can go really quickly from the concept phase to prototyping, or prototypes being created. It's similar to 3D printing in that way. It might not be that suited for mass manufacturing in a lot of cases, but it's really good for prototyping. design flexibility. You can do a lot more geometries than you would be able to do with stamping, unless you had really complicated and expensive molds that are in multiple pieces and kind of come together and release the parts. And low startup cost. You might think that one or two six-axis robots are not expensive, or are very expensive, and they are, but when you compare them to all the tooling costs of stamping, it's a pretty low startup cost. And then the cons: not good for high volume manufacturing, poor surface finishes unless you go through a lot of post-processing, and it's a very slow process to actually make the parts. Stamping is just one big press usually, and this incremental forming can take hours or maybe days depending on the geometry you're trying to create. All right, that's it. Thank you very much.